Good morning. Today's objective is, how do we classify real numbers? The language objective is, I can explain how to classify real numbers. What are natural numbers? Natural numbers are counting numbers. What are integers? Numbers without a decimal. Rational numbers? Numbers that end or repeat. Irrational numbers, the opposite of rational numbers. Numbers that do not repeat nor end. Rational numbers can be converted into a fraction or a ratio. Rational, ratio. Irrational numbers are crazy. They cannot be converted into a fraction. What are some examples of natural numbers or counting numbers? Well, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. Those are all natural numbers. Integers. What are integers? Well, whole numbers without a decimal. They can be positive, they could be negative, they could be 0. Rational numbers could be almost anything, but it's got to repeat or end. So we have -2, -1, 0, 1, 2, 3. Those are all rational numbers. But we also have a fraction. It could be converted into a fraction of 2/3. That's our ratio, 2 to 3. 2 boys to every 3 girls in the classroom. That's a lot more girls in the classroom than there are boys. That's a ratio. Square root 25. Why is that rational? Well, what is the square root 25? If we put it in the calculator, you're going to get 5. Because what's 5 times 5? 25. 2.37373737, that's repeating, so it's rational. 0.37 with a bar over it. That line means repeating. So that means 0.37373737. It's repeating. It's rational. 3.14 is, it looks like pi, but it's not. It stops. If it stops after the 4, then what number comes next? 0. And after that, another 0. It ends. It stops. It terminates. So that's why it's rational. Irrational numbers. One example would be -2.382741193. It goes on forever, and it doesn't repeat. It's got different numbers. Square root 23. If we put that in the calculator, what do we get? Let's see. I'm taking my calculator right now and turning it sideways on my phone. Square root, so we're going to put in 23 and then the little 2 square root. So I get 4.79583152331272. That's not rational. That's irrational. It has no rhyme or reason. It just goes on forever with random numbers. That's crazy. That's irrational. Pi is irrational because it goes on forever with random numbers, but it has to be written with an actual pi. So if it's written like that, it's 3.14159265358897. That's a lot. That's random numbers forever. It doesn't repeat. It does not end. And it cannot be converted into a fraction. You could put a fraction next to it and it's still crazy irrational. Please copy these definitions. Integers. Here are some real-world examples of integers. We have temperature, which can be positive or negative. If it's positive, it's hot. Positive 120 is really hot. If it's negative 60, that's very cold. On the right, we have a boat at 0. We have a fish at negative 20. The fish is 20 feet below the boat. And we have a bird. The bird is 35 feet above the boat. These are all integers. Natural numbers. When we are measuring a door or a table, it's always going to be positive numbers. Have you ever heard of a door measuring 5 feet but negative? Negative 5 feet? No, it's got to be positive. Would a table be 0 inches wide? No, that makes no sense. When we're measuring cups and ounces, those numbers are positive, so those are also natural numbers. The weight of the apples in this picture is 2.5 pounds. How many sheep do you think there are? I like to count sheep before I go to bed sometimes. Well, I don't really, but a lot of people do. So those are natural numbers because those are counting numbers, counting sheep. I think there are about 100 sheep. Just a guess. I'm estimating. So those are natural numbers because you can count them. Pi. Pi is irrational. It's crazy. It goes all over the place and it never stops. So on the right, we have an example of pi. 3.14159265358979323, and it goes on forever, but with different numbers. That's crazy. That's irrational. The pi on the left is an example of why pi exists. So take the blue circle, that's C, and divide by the red line, that's D. So take the circumference divided by the diameter, that's pi. It works for all circles, small circles and big circles. Now we're going to put these terms, these vocabulary words, into a graphic organizer. In the gray section, we have irrational numbers. In the white section, we have rational numbers. So within those rational numbers, we have integers, which could be positive or negative. If they're just positive, they're called natural numbers.